Hello, in this video, I'm going to be showing you how to identify how many stereoisomers that are possible for the compound on the screen. The first thing to do is to identify all the chiral centers in the compound. Before we do that, let's identify all the carbons in this compound. In a skeletal compound, the carbons are not written out. The hydrogens are usually not shown as well. This is a carbon. This is a carbon, this is a carbon, a carbon, a carbon, and then a carbon. Now, to fill up all the hydrogen, we have to remember that carbon must have 4 bonds surrounding it. So this is 1 bond, which means we're going to use 3 more hydrogens to complete the 4 bonds around carbon. For this one, you have 3 bonds already, 1, 2, 3. Okay, so we only need 1 hydrogen to make up the 4 bonds. This one is totally full. You have 1, 2, 3, 4. So that is full. You don't have to put any hydrogen. This one right here, you need to put 2 hydrogens because you only have 2 bonds, while this would have 3. And there's one more here. This also has 3 hydrogen. Now we filled up everything. We can go ahead and locate which of these centers or carbons have 4 different groups attached. That's what makes it a chiral center. So this carbon right here has 1, 2, 3, and then 4 groups attached to it. So this makes this a chiral center. So we have 1 chiral center at the moment. This one over here has 1, 2, then 3, plus this side, 4. 4 different groups surrounding it. So that makes this another chiral center. Okay? While the others, they do not have 4 different groups attached, so they are not chiral. Now that we've identified the total number of chiral centers, the formula to solve for stereoisomer is 2 raised to the power of n, where n is 2, that is the total number of chiral center. Okay, so to calculate our stereoisomer, you're going to just say 2 raised to the power of 2, which is going to be 4 stereoisomers.